Hello, 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 everybody. Root Beer here with question number 23 now on the 2004 Fermat paper. So let's take a look here. Question number 23. Triangle ABC is isosceles. Okay. So immediately I'm starting to think what sides, and we're going to have two angles that are the same. So AB is equal to AC. Fantastic. And we're also told that BC is 65 centimeters. Okay. Just looking at the picture, I'm seeing some right angles, so I'm trying to think. Pythagorean triples, maybe, somewhere in there? I don't know. Certainly Pythagoras might play a role. Then again, these right angles could just be altitudes of these smaller triangles. Who knows? P is a point on BC such that the perpendicular distance from P to AB, so that would be to R, and AC are 24 centimeters and 36 centimeters respectively. So RP is 24 and PS is 36. These aren't ringing any particular bells. I mean, maybe PR is 24 and then RB is 7 and PB is 25 or something. Maybe. I don't know. The area of ABC in centimeters is... Okay. I think the best thing to do might be just clear our heads for a moment and draw the picture. If I'm going to draw it that big, I probably want another sheet of paper, just so that I can keep referring. Because if I draw it that big, I'm going to make maybe one or two statements where I have to flip the page and draw it again. So let's draw it up here. That's too curvy. See if we can get a straight one this time. There we go. So it's isosceles, so I'll put the apex about at the middle here. And P is probably not at the middle, just the way they've got it constructed. I would say if P were the middle, then it'd be symmetric, and both the perpendicular distances would be equal, but one of them's 24, the other's 36. Okay. So here's P, here's A, C was over here, and B was over here, as I recall. Not that it particularly matters. What do I know? I know we've got 24 in here, 36 here. Overall, this is 65. And they're isosceles, so AC and AB are the same, and the lengths are fine. But something else, they've got to have the same angles here. The angle at the top, I don't know what it is, I don't really care what it is, but I do know that since they're opposite identical side lengths, they must be identical angles. And if that's the case, we've got a red angle, a 90 degrees, and a green angle. Here we'll get a red angle, a 90 degrees, and a green angle. These triangles here are going to be similar. Okay? So they have to be, the green angle has to be 90 minus the red angle. It's going to be the same in both cases. So triangle PRB is similar to triangle PSC. Yeah, I've got the right angle is the one in the middle, so that these are lined up properly. Not only that, they're similar. I can tell you the common ratio. So PS over PR, PS over PR should be the same as PC over PB, which should be the same as SC over RB, but PS is 36 and PR is 24. Take out a factor of 12, the whole it's going to be 3 over 2. So this PSC is 3.5 times as big as PRB. All the lengths are extended by 3.5 times. That would also mean the area is extended by a certain amount as well. So, okay, so that's nice, and that should get us the ratios here, PC and PB And I know they have to add up to 65, so I think that'll work that out. But something else I just thought of. We ultimately want the area of ABC, right? So if I had an altitude here, the base is 65. If I just knew what this altitude was, I'd be all set. But then we've got a right angle. We've got this red angle. We're going to have this green angle up here. And so we're going to have triangle PRB. I call this maybe T. This is going to be similar to triangle ATB, whose area is 1/2 of triangle ABC. So there's another similar triangle in there. I don't quite know how we're going to use this guy, but I really do think we're going to use ATB. What else? Okay, so I said because we got this common ratio, I know 65, that's a G. I don't know why I wrote a G when I wanted to write a 6. 65 is BC, which is BP plus PC. But PC is 3.5 times BP. So 65 is 5.5 times BP. So divide both sides by 5, we get 13 is 1/2 BP, multiplied by 2, so 26 is going to be BP. Okay, so 26, that's fine. Put a 26 down here. And then what's left over? 39, right? Okay. Is that enough to work out ratios? Because if I knew the ratio, I could figure out what AT is. Ultimately, what I want is just AT. If I could get it length AT, that'd be fine. Now, AT over PR is the same as BT over BR. BT here is 1/2 of 65, because he's the midpoint. He's got to be the midpoint. He's an altitude. So that's one number. PR is, so this is AT over 24. So if I just knew BR, I could work out what AT is, and once I had AT, I would have the altitude, base, get the triangle, 1/2 base times height. So I just need BR, and BR is the other length in my small right angle triangle PRB. Okay. So PRB is a right triangle. So you can either say by Pythagoras, or if you know your because it's not a written question, so you don't have to prove anything, or if you know the 5, 12, 13 triangle, which this has turned out to be, 26 is 13 times 2, 24 is 12 times 2, so this should be 5 times 2, which is 10. So you can either know that, or you can work this out. BR squared, the thing that we want, is going to be PB squared, 26, minus PR squared, 24. This is 576, and this would have to be 676, but it's been a while since I had to do 26 squared, so I'm going to bring out my calculator and just double check. Never hurts. We've got them on the contest. Why not use them? Yes, it is 676. This is going to have to be 100. BR is 10. Okay. So now AT over PB is the same as BT over, I'm just trying to remember the diagram. I know I wrote this out a second ago, but I have to think about the BR, the thing that we just solved for. So AT over PB is Oh, we don't want PB, we want PR. Right? Because they're both the altitudes. So 24, and then we have 1/2 65 over 10, which is 65 over 20. So AT is going to be 24 times 65 over 20. Let's see, I can get a factor of 4 out from there and a factor of 5 out from there. That eliminates the 20. 6 times 13 is 18 plus 60, so 78. So AT is 78. Does that make sense? If I divide this by... No, I can't divide this by 12. If I do divide this by 12, what do I get? I get 13 over 2. And if I multiply that by 5, I get 65 over 2, which is the... Okay. Everything works out. So now, triangle ABC, the thing we want is 1/2 base times height. So this is 65, and the half and the 78 will cancel out to give me 39. 65 times 39, that would be 5 times 3 times 13 squared. That would be 15 times 169. I thought if I could rearrange it that I could just do it in my head. I can't. So 15 times 169. We get an area of 2,535. That seems a little high, but that's one of the answers. D, so that's what we're going with. Does that all check out? Yeah, I think so. Yeah, I think it's all fine. I'm a little worried. Maybe I made a calculation mistake somewhere in here, so I'm just going to try and mentally go through this again. It's always good if you got a nagging doubt that you've done something wrong. Check to see if you have an error, even if some of the ways they make up the wrong answers on the multiple choice ones is by making a tiny little arithmetic mistake somewhere. So let's see. 36 to 24 is 3 over 2, and that does give us those ratios. That does give us 26 and 39. AT would be a base of 65 and a half. 65 and a half to 10 is 65 over 20. That should be the same as AT over PB. So yeah, okay, it all seems to check out. Okay, so D it is, and that's question 23. So in the next video, we're going to take a look at question number 24, our penultimate contest question. I hope to see you there.